Hey, good evening, everybody. Pushing good morning. Um, so had a couple people ask me to look through and make a video on this. So we're at page 247, doing 10 through 13. So this is about using corresponding parts of congruent triangles. So basically how this is going to break down. And we'll go over it a couple times once we get started. First thing we need to do is prove the triangle's congruent. So in each of these problems, we're going to have a couple triangles. We're going to need to prove them congruent. And then based on that, we're going to need to prove, we'll be able to sit there and look at the different parts of the triangle. And once we prove, so then the corresponding parts of congruent triangles congruence. So before we get started, I want you guys to remember that we've done this a couple times. If triangle ABC, or ADC, that's fine, is congruent to triangle, say GEF, then inherent in that is that angle A is congruent to angle G, angle E is congruent to angle D, and angle C is congruent to angle F. Moreover, side AD is congruent to side GE, side DC, that's DD, never mind, is congruent to EF, and then side AC is congruent to GE. So notice what I'm doing here. So I start off by saying the first and the first are congruent. First and the first, there we go. Then second and second, then third and third. Those are the angles. Sides, first two to first two. Second two to second two. First last to first last. So keep that in mind as we go. So over here, we're looking at number 10. And what we want to do is we're given three facts, YT, YP, CR, and TP are all congruent. And we want to use those three facts to somehow prove that CT, that's this line right here, and RP are congruent. So what we're going to do is we're going to start writing down our givens. So first we have that YT is congruent to YP. That is given. Next, we have that R and C are are also congruent. That's given. And finally, we have angle T and angle P congruent. So it's given. So that's what we're given. So now what I want to do is just write all that down as a kind of semi-paragraph proof. Given YT and YP, given C is congruent to R, and T is congruent to P. Now, if we look at that, we can then go, hey, that's angle, side. So we go CTY. Whoa, that was a bit much. Angle CTY is congruent to angle RPY by side, or angle, side, sorry. AS. Okay. So now that we have that, we can sit there and say that CT is congruent to RP because corresponding parts of congruent triangles are congruent. Remember that for that, you can also write C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So, now what we just did basically is we sat there and we said this triangle is congruent to that triangle. and we use the givens. We use the angle side theorem, and said that because of that, those two angles, which are corresponding in their nature, they're in the same parts. Remember, look over at how we have CTY is congruent to RPY. Notice that those first two letters are congruent to the last two letters, just like right here over on the left-hand side. So that's all we're doing. We're proving that these triangles are congruent, and then because when we say that triangles are congruent, we mean that all three of the angles are the same and all three of the sides have the same length. So once we prove an angle or a triangle congruent by using side, 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 angle, angle, or angle, angle, side, if we can prove a triangle congruent with any one of those four, then really all we have to do is then say because they're congruent, the corresponding parts are also congruent. So these next three, 11, 12, and 13, we're going to be doing basically the same thing, but all of them have to do with that triangle over on the right. Triangle KPQ. Now what we need to do for each of these is prove that these two angles are the same, P and Q. So how we're going to do that on each one of these, 11, 12, and 13, so we're going to prove that this triangle is congruent to that triangle. So we're going to always have to prove that KPL is congruent to KQL. Once we do that, we can prove that angle P and angle Q are congruent. Because again, corresponding parts of congruent triangles are congruent. So 11. So what I'm going to show you is I'm basically going to talk through it. What I'd like you to do is you'd actually try and sit there and actually talk about how you do the proof. Try and write it down on paragraph form or 2-column. Either way is fine. So for 11, we're given that KP and KQ are congruent and that KL bisects PKW. So again, we need to remember what bisects mean. And that is that it cuts whatever in half. If it's bisecting an angle, it cuts the angle in half. If it's bisecting a segment, it cuts the segment in half. When it does that, it cuts it bisect cuts it into two equal pieces. So we know that those two angles are the same. We look up there, we also see that KL is congruent to KL. That's the reflexive property. And hey, look, we have side angle side, side angle side. So we can then know that KP or KPE KPL and KQL are congruent. Once we say that those two are congruent, then we can sit there and say that corresponding parts of congruent triangles are congruent, or that P is congruent to Q. And that would be by side angle side. So next, I'm going to walk through all three of these. Again, I'll show you kind of what the theorem is behind it, but I want you guys to actually sit there and work on the proof part. So here, we're told that KL is the perpendicular bisector of PQ. So that means that it hit perpendicular, hits at 90 degrees, bisector, cuts in half. We just went over that. KL, still KL, so that would also give us SAS, because you have side, angle, side, side, angle, side. Again, once we prove that KPL is congruent to KQL, we prove that P and Q are together. So finally, we're told that KL and PQ are perpendicular to each other. So they've got the 90, and we're also told that KL bisects PKQ. So remember, bisects mean cuts in half, and halves are equal to each other. So here we have that one side going down the middle. Yeah, I just had a side going down the middle. It's okay. So you have that one side going down the middle. you have congruent angles on either side in both triangles. So that's going to give you angle, side, angle. Again, it's angle, side, angle, not angle, angle, side, because it is in between the two angles. Previously, we went over AAS, and remember that is angle, angle, side. And again, you should read this how it actually would look in real life. If I look down at angle, side, angle, I'm expecting to see a side, a congruent side in between two congruent angles. If any of this doesn't make sense, feel free to go ahead and rewind it. Also, come and talk to me lunch after school. Thank you very much, and have a good evening, everyone.